Alright, welcome to the video tutorial for Unit 4. I'm going to assume that by this time you've already downloaded the SPSS data file for Unit 4, and we'll get started. To begin with, I'd like to reiterate some of the information you covered in the reading and in the other video, and talk a little bit about what t-tests are and how they're used. In essence, a t-test is a way of comparing averages. So it can be used to test if a sample mean or a sample arithmetic average is a good approximation of a known population mean. When we say approximation, we mean is it close enough to that population mean or far enough away from that population mean for it to be different. And generally, we're interested in saying that it's far away enough. So we call these tests difference of means tests. It can also be used to test difference of means in two other cases, in what we call dependent and independent samples t-tests. Generally, when we're talking about dependent samples t-test, we're talking about two observations of the same cases for the same thing but at different times, essentially a before and after test. And in the case of the independent samples t-test, we're talking about one observation each on the same issue of two groups of cases. So for instance, comparing residents of Michigan and residents of Ohio based on their average income. Right? In using t-tests to make these comparisons, we engage in hypothesis testing in a very formal way. So we develop a theory about our data, right? And I don't mean a broad, grand theory. I just mean something that we think is going on with the data. And in a very particular way, we talk about what we think is going on and how we can demonstrate that. And this is where the principle of falsification becomes very important. Falsification is the idea that we have some notion, some hypotheses that we hold up and say, let's do everything we can to knock this down. And if it still stands, then it's good. If it doesn't, then we falsified it, and we can move on to testing the next thing. So the way we do that is through the use of the null and the alternative hypotheses. We have our theory, we phrase it essentially in two ways, the null hypothesis and the alternative hypothesis, and we see if we can reject the null hypothesis or if we fail to reject the null hypothesis. And that tells us whether we falsified what we've done. So when we find a statistically significant difference, we say we reject the null. We say in every case that there's no difference in the mean values for our t-tests. Right? It's some variation always on no difference. Nothing is happening, right? So when we do not find a statistically significant difference, we fail to reject the null. You want to avoid that phrasing that says that you accept the alternative, right? You either reject the null or fail to reject the null. It's just the method by which it's done. It's the principle of falsification at work. And since we're generally looking for these differences, we're happy to reject the null. Rejection in this case is a good thing, right? Okay. So how do we go about testing a hypothesis about a single mean? Well, in this case, we're testing to see if a sample mean, some data you have on a particular issue for a particular variable, is different from some known population mean. So, for instance, we might be testing the income of residents of Saginaw County against the average income across the state of Michigan, right? So we have this sample, all the people we know of in Saginaw County, against some known population mean. We get that known data from the state of Michigan or from the federal government, but we already know what the average for the state is. And we want to know if the average in our county is different. So a clear statement of the null and alternative hypotheses in this case would be The null, that there's no difference between the population and the sample means, very simply phrased, and the alternative, that there's some difference between the population and sample means. And once again, we're attempting to reject the null in favor of the alternative hypothesis in order to demonstrate that our sample is different from the population, right? But always reject the null when you write about it. And you'll see I've included in your instructions some sample language that you can feel free to mimic, and it should make it very easy for you to write about it. When testing hypotheses about two related means, we're looking at a different type of t-test. The first one was the one sample t-test. Now we're talking about a paired sample t-test or a dependent sample t-test. Lots of different names for this same procedure, but it describes the same thing. It describes taking a value once, letting some time pass, and taking another value. Two measures for the same cases over time. So what we're testing to see here is if your first observation is significantly different from your second observation, to see if it's reliably different, see if you know with a reasonable degree of certainty that it is different. So we have a clear statement of the null and the alternative hypotheses. We have the null hypothesis that there's no difference between the first and the second observations. Once again, see, the null is no difference, nothing, nada, ain't nothing going on. And the alternative hypothesis that there's some difference between the first and the second observations. And here, once again, we're attempting to reject the null, and remember to say reject the null when you write about it, not accept the alternative, but that's really what we're doing. But say reject the null. You can say reject the null in favor of the alternative if you'd like, but reject the null in order to demonstrate that a change has occurred due to some intervening event. So for an example here, let's say you have high blood pressure. We have 200 people that have high blood pressure. We give them all blood pressure medication. After taking a first measure of their blood pressure, we administer the medication, we take a second measure, and we see if it had any effect, right? It's just a before and after test. And then testing hypotheses about two independent means, or the independent samples t-test. And here we're testing to see if a mean is shared by two independent groups of cases. Generally, we're interested in showing that that mean is not shared. That's the essence of rejecting the null here. So there are clear statements of the null and alternative hypothesis in each case. The null is that there is, once again, no difference between the means. And the alternative is that there is some difference between the means, right? And we're attempting to reject the null in favor of the alternative hypothesis in order to demonstrate that there is a difference between the means. So for instance, if we were interested in illustrating the difference in income between men and women in the population of Michigan, we'd take the average of the income of men, the average of the income of women, and use the independent samples t-test to compare those two things. All right. Let's move on to the unit instructions, and I'll walk you through some of the examples and let you complete the rest on your own. So finding SPSS, opening the data set. Once you have it open, let me orient you to it. So go ahead and pause until you get it open, and then I'll start again. All right, this particular data set is a data set of course evaluation and course assessment data from PS 118, Introduction to Political Science. Essentially what it is broken down by professor, a group of students who have taken a pre-test and a post-test at the beginning and at the end of taking PS 118 to see if they've learned anything. So we have a variety of variables here, and you can see the variable names here, the familiar case ID, and then prof, which is the professor in question. In this case, it's myself, Professor Kaczynski, Professor Trump, and Professor Trepanier. The GPA of the respondent, of the student in question, whether or not that student is cohabitating with a significant other, right? You guys know cohabitating, right? Shacking up. What that student's major is. I can see there are a variety of responses to that, right? Business, education, social work, chemistry, nursing, political science. That's everyone that was included in the data set. And then their class standing, their year in school, freshman, sophomore, junior, senior. And then their final grade in the class. And this is a course grade. That's just A, B, C, D, F grade. The age of the student, their gender, and you can see it's coded. 0 for male and 1 for female. And then the pre-test score, it's a percentage score. The post-test score, which is also a percentage score. And a second post-test score given later in the semester. And those are all percentages. We have a variable in there that asks about their use of technology and what percentage of their time they estimate, their waking hours they estimate they use technology, whether it's Facebook, email, watching Netflix, whatever. And then their final grade is a percentage. Don't confuse this percent grade with the final grade up here, right? The final grade up here is a string variable. It's just words. You can't do any math with it. This percent grade, very handy for doing a little bit of math, like the t-test. And then we have a dummy variable here, a 0-1 variable here, that tells whether or not they passed the class. 0 is failed, and 1 is passed. All right, let's look at the unit instructions so I can run through some of these with you so you have something to work with as you do your own. All right, let's try number 2. Perform a one-sample t-test for the variable GPA using a known population average of 2.72. So what are we about here? Well, what we're about here is trying to figure out whether or not the average of the folks in this data set, the grade point average of the folks in this data set, is different than the average of the average SVSU student. That's a lot of averages. But we're trying to figure out if the GPAs for this group of students are different than for the university as a whole. So first we want to specify the theory. The theory here is just that the group of students being assessed in PS 118 have a different GPA than the general group of students at SVSU. The null hypothesis is that no difference exists in the GPA between the sample and the population. The alternative hypothesis is that some difference exists between the sample and the population. And here's how we do it. We go to Analyze, Compare Means, One Sample T-Test. Okay, and this is what we get. I'm going to change to the variable names because that's what I've used in the instructions. We're interested in GPA, the test value. This is the known population mean for SVSU students is 2.72. Now, I'll bet you some of you probably thought the grade point average was higher than that. I've gotten that from a lot of classes in the past. They thought the average grades were much higher. But this I got right from institutional research, and that is factual. So maybe some people have been pulling your leg a little bit about their GPA. Who knows? But anyway, so here's what we've got. We're testing the average GPA from the sample of students from PS 118 against the known population average from the university. So what do we get? These are the results we get. So what do we have? We have 234 cases with an average of 3.0227. right? That's what we're interested in. So that's the average, 3.0227. That's the average for the students that have been tested for this class. Now, how do we figure out if that average of 3.0227 is different than this test value of 2.72, or different enough to matter given the conditions under which we're measuring it? Well, eyeballing that, it looks pretty different, right? You'd probably think that was statistically significant in its difference, and you'd be correct. So what do we have to look for here? We have to look for the t-test. And this is the important information about the t-test, right? The value of the t-statistic, right here, 7.560. The degrees of freedom, 233. And the two-tailed significance. Now, in writing about these results, you need 4 pieces of information, right? The mean, the value of the t-statistic, the degrees of freedom, and the alpha level, right? The p-value, so you know if it meets or exceeds or falls short of the alpha level. And this two-tailed significance is the same thing as p-value, is referring to the same thing as alpha level. We're all talking about, all these things are talking about the same thing. It's whether or not we're getting a false positive result here. Whether or not we have a reliable result that tells us that what we've measured here is really different than the population average. So, let me drag over the unit instructions, and I'll scroll down to the model language and give you a peek at what I'm talking about, right? Where we have to plug things in. So, there's a theory right here that I was talking about. The students in our sample from PS 118 have a different mean GPA than the general population of SVSU students. The null hypothesis, no difference, exists in mean GPA between our sample and the population. The alternative hypothesis, some difference exists in mean GPA between our sample and the population. All right. So these are slightly different numbers from an older data set, but consistent with what we've seen here. So you'll need to plug in the correct numbers when you do your writing about it. All right. Plugging in the numbers here. In this example, we have the mean for the population, the mean for the sample, the degrees of freedom, the value of the t-statistic, and an alpha level of 0.05. I've chosen the easier path here. You can report the exact alpha level, and you can read about that a little bit in the instructions above. But it's fine to just use 0.05 as your alpha level, as we do for so many things. All right. And of course, in that case, we reject the null. That no difference exists between the population and the sample means because some difference does exist, in favor of the alternative hypothesis that some difference exists. Or, I've given a second example below here that shows what to do if you fail to reject the null. If the p-value is greater than 0.05. Remember, that's the defining characteristic here. What you're really interested in finding out is about this, about the 0.05. If it's lower than 0.05, reject the null. If it's higher than 0.05, fail to reject the null. If you do find yourself in a condition where it's exactly 0.05, you can still reject the null. Okay. So that's the one sample t-test. Let's move on in the instructions to number 4. You'll be doing number 3 on your own, which is a one sample t-test for the variable age using a known population average of SVSU students of 20. You'll want to walk through it just the way I walked through the example. Using GPA should work out just fine. But let's move on to number 4 and perform a dependent samples t-test for the variables pre-test and post-test. Now, as you're doing this, be careful. There are 2 post-test variables. One of them is labeled post-test 2, so make sure you don't use that one for the test we're about to do. That's for your next one, and we'll do that right now. Let's do that first one. So, analyze, compare means, paired samples t-test, which is another name for the dependent samples t-test. As you know by now, many different names, but this is what we're talking about. It's the paired samples t-test. We want to look at 2 variables, the pre-test, drag it into the box over here, and the post-test, drag it into the box right next to it. Right? Not underneath it, not in row 2, both in row 1, variable 1 pre-test, variable 2 post-test, and hit OK. And you should get something that looks like this. What do we see here? We see a mean for the pre-test score, 74.51, and a mean for the post-test score, 76.06. Right? So that's a difference, but is it different enough to matter? Now, this is a little touchier because it's not as simply laid out as the last one. We want to look very carefully to find the things we need. Once again, we need to know the 2 things I just pointed out to you. The averages for the pre-test and the post-test, right there. And then we need to know the value of the t-statistic, and whether that t-statistic is negative or positive is irrelevant. It's irrelevant. What we're concerned with here is the absolute value, so that's fine. The degrees of freedom, and the 2-tailed significance. So what we can see here, and what we're most interested in, as we always are, is the p-value, the significance level. And that is 0.032, which is well below 0.05. So what do we do in this case? We reject the null. We reject the null in favor of the alternative, and we say that there is some statistically significant difference between the pre-test and the post-test scores. And by looking at them, we know that difference is about a 1.5 improvement across the sample. So let's jump back to our unit instructions and see how that gets plugged into the paragraph. Right there. See? So theory and hypothesis all laid out there for you. Results show that the post-test score, there's a mean, the post-test mean, were significantly higher than the pre-test scores, the pre-test mean, right? The sample size, right there, is the degrees of freedom, which is actually the sample size minus 1, right? So the degrees of freedom and the value of the t-statistic, and most importantly, the p-value of less than 0.05. Right? Now, if in the case we had not had a statistically significant result, it would just be phrased the way it is in the paragraph below. You'd still report the means, you'd report the degrees of freedom, the value of the t-statistic, and remember, change the sign here, that p is greater than 0.05. So in this case, we'd fail to reject the null hypothesis that no difference exists between the pre- and post-test scores. All right. Scrolling back up. So that's number 4. You can do number 5 on your own, and that's just the same as this, except you use post-test 2 instead of the regular post-test variable. Okay, moving on to number 6. We want to perform an independent samples t-test for the variable percent grade using the variable cohab to define the categories. So what would our theory be here? Our theory would be maybe that people who are cohabitating have lower percentage grades in the class. Maybe our theory would be higher. It doesn't matter. As long as you have some theory to test and your hypothesis conform with that. What we're really interested in is the hypothesis testing. And our null hypothesis in this case, of course, would be that there's some difference in the percentage grade between those people who are cohabitating and those people who are not cohabitating. The alternative hypothesis would be no difference. And I guess we can just go ahead and check that. So let's do that. So back to SPSS, analyze, compare means, independent samples t-test. Now watch carefully on this one. We're interested in the percent grade, second from the bottom, percent grade, and our grouping variable. The categories we want to differentiate between are those people who are cohabitating and not cohabitating. Now you see, here where it says cohab, it's followed by 2 little question marks. It means we need to still define the groups. As I mentioned before when I was walking you through the data set, the groups are broken up 0 for those people not cohabitating and 1 for those people cohabitating. Works every time with cohab, and we're very, very certain with this one that it's 0 and 1 because we looked in the data set. Same thing later on when you go on to using gender. It's coded 0 and 1. 0 for males, 1 for females. Works exactly the same way. Hit continue and hit OK. Now this gives us a big old table. It's got a lot of information, but only a few pieces of it we really need for our purposes. Let's see, what are the sample sizes? Not cohabitating, 183. Cohabitating, 51. What's the mean percent grade for those not cohabitating? 77.73. 77.73. And the mean for those cohabitating? 77.25. That seems pretty close. Let's check. Now don't get confused on this table because it's reporting some things you don't need. There's an F test over here that's not important to us at all. What you're interested in is everything here in the middle from T to degrees of freedom to two-tailed significance. That's the stuff you want to get. Just like our other tests, we want to check and see that we have a value for the T statistic. In this case, 0.205, very low. Degrees of freedom, 232. And the significance, 0.838, which is way, way higher than 0.05. So in this case, we fail to reject the null. We haven't met the standard of having a significance level at 0.05 or under. So we fail to reject the null. All right. So what does the language for that one look like? Well, pretty much like the language for the other ones. I want to specify a theory and a hypothesis. All right. Report it with a mean. In this case, it's a different example. I've used mean GPA, but works the same way. You report it with the mean. In the case of the example we just did, we'd report the mean percentage scores. We'd report the degrees of freedom, the value of the t-statistic, and whether or not it was above or below 0.05. Of course, for the example we just did, we would use this one because it was a case where we failed to reject the null. But at this point, I'm sure you're catching on. You see things clearly and how they're structured. Shouldn't be any problem for you to plug the right stuff in. Okay, so jumping back to the unit instructions, after you've done number 6, in number 7, I've laid out a series of variables for you to test using the independent samples t-test, and the categorical variable, the dividing variable, the grouping variable, gender. So I want you to test the difference between men and women on GPA, the difference between men and women on age, the difference between men and women on pre-test scores, on post-test scores, on the number or on the percentage of time they spend using technology, and on their percent grade in the class. And for each of those variables, of course, specify the theory, a null hypothesis, an alternative hypothesis, and interpret those results using the model language. And that'll be it for this week's assignment. As always, if you have any questions, feel free to hit me on the discussion board or to email me, or even better, come to lab on Monday morning. I'll be there at 10:15 ready to go, so if you have any questions, let me know.